All right, so we're going to move into section 1.2 and talk about evaluating functions algebraically. In section 1.1, we started by looking at 4 different ways to illustrate a relation. We saw we could do it by listing all the ordered pairs, drawing a graph, making a table of values, doing a mapping diagram. Those methods, though, are only good if we have a discrete relation or a discrete function. When we have a continuous function, well, we can't list all the ordered pairs. We can't make a table of values for everything on that function. We can't do a mapping diagram. There are really only 2 ways we can show a continuous function. I can draw the graph like we looked at in the previous section, or I can create a formula for that function, and that's what we're going to look at over here. Our notation to show the formula for a function looks something like this. I have a function I'm going to call f of x. F of x is the way we read that, equals 2x plus 3. When we have a function, there's a particular input, and we get an output. Whatever I fill in inside the parentheses here will be my input. And for this particular function, f of x, this formula over here will give me my particular output. I promise this is nowhere near as complicated as that sounds. If I want to find f of 1, that means I'm going to plug 1 into my function where the x is and see what I get for an output. Well, f of 1 is going to be 2 times 1 plus 3. I'm just plugging in a 1 where the x is. Well, 2 times 1 plus 3, that's 2 plus 3. That's going to give me 5. F of 1 is 5. If I now want to find f of 6, when my input is 6, what's the output? Well, I'm going to go plug in that 6 where the x is in my formula over here. I'm going to get 2 times 6 plus 3. 2 times 6 is 12, plus 3, and I'm going to get 15 out of that. I tell you an input and I give you a formula, you plug it into the formula, and you get an output. Let's try a couple. I have 3 functions given over here. F of x equals 2x minus 2, g of x equals 4 minus x, and h of x equals x squared plus 1. You're going to find a couple things, and when you find them, make sure you're showing your work. I don't just want the number answer. I've got to see where that number's coming from. Take a moment and find problem number 1, f of 3. What's f of 3? Well, I'm going to go plug 3 into my f function. I'm going to get 2 times 3 minus 2. 6 minus 2, I'm going to get 4. What's f of 7? Two times 7 minus 2, that's 14 minus 2. I'm going to get 12. Moving on to the g function. Number 3, what's g of negative 2? G of negative 2 is 4 minus negative 2. Remember that double negatives really become an addition problem, so 4 plus 2. And we're going to get 6 out of that. Number 4, what's g of 0? This is 4 minus 0. 4 minus 0 is 4. Number 5, h of 3. H of 3 should be 3 squared plus 1. 9 plus 1, we're going to get 10. Number 6, h of negative 5. Okay, well, whenever I have a function that involves a square, or really any function I suppose I probably should have done this in, whenever I go to plug in something more complicated than a positive whole number, I'm always going to put the thing I plug in parentheses. So I'm going to get negative 5 in parentheses squared plus 1. Negative 5 squared means negative 5 times negative 5. Negative 5 squared should give you positive 25. 25 plus 1 will give you 26. The parentheses are really important because if you go to your calculator and type in without parentheses negative 5 squared plus 1. Your calculator is probably smart enough to do order of operations, which says, let's deal with our square before we deal with, well, this negative is really like saying negative 1 times your thing. Let's square it before we deal with our multiplication. And it's going to say that negative 5 squared with no parentheses is negative 25 plus 1, or negative 24, which is not what I want here. Because I want you to show that you're squaring the entire negative 5, you've got to make sure it goes in parentheses. Now, problems that are a little bit tougher. In number 7, we want to do 2 times g of 3 plus 4 times h of 0. And you know what? We're not going to try to do this whole problem all at once. Instead, we're going to start by just finding g of 3, and then we're going to find h of 0. Once we're done with that, we'll put everything together and try to do the entire problem. For starters, take a moment and go find g of 3. G of 3 is 4 minus 3, or 1. Probably shouldn't have circled that because that's not my final answer, just 1. Next, h of 0. What's h of 0? H of 0 should give you 0 squared plus 1. That's 0 plus 1. That's 1. If I want to now go back to the original problem, the original problem said do 2 times g of 3. Well, what is g of 3? 1. I already figured that out. Plus 4 times h of 0. What is h of 0? Already figured that out as well. It's 1. Final answer here, 2 plus 4. My final answer is 6. Don't try to do this all at once. Figure out g of 3, get an answer. Figure out h of 0, get an answer. Then do 2 times g of 3, 2 times 1, plus 4 times h of 0, 4 times 1, get your final answer. Number 8, you're not going to try to do this all at once. You're going to go find f of 10. Actually, go do that right now. What is f of 10? 2 times 10 minus 2, that's 20 minus 2, that's 18. Go find g of negative 5. G of negative 5 is 4 minus negative 5. The double negatives will turn that into an addition problem, so 4 plus 5, I'm going to get 9. Go back to the original problem now. What's f of 10 divided by g of negative 5? F of 10 divided by g of negative 5, that's just going to give me 18 divided by 9. I'm getting 2 out of that. That's it. So we've seen how to plug numbers into functions, but we can also plug variables or things involving variables into functions. Turn the page. I again have the same 3 functions, f of x, g of x, h of x, and I want to figure out, in number 9, f of w. Well, if number 9 asked you to find f of 3, you would plug in a 3 where the x is. It's asking us to find f of w, so I'm going to plug in a w where the x is. When I do that, I'm going to get 2 times w minus 2. There's nothing more you can do with this. So I'm going to put a box around it and be done. F of w is just 2w minus 2. In number 10, I want to do f of 3w. I'm going to replace the x here with a 3w, and I'm going to plug it in parentheses because, again, this is more complicated than a single positive whole number. I'm going to get 2 times in parentheses 3w minus 2. Well, 2 times 3w, that's 6w. And I'm going to get a final answer of 6w minus 2. Next, in number 11, I want to do g of negative 2x. I realize this is a little bit strange because I'm going to replace this x with the more complicated negative 2x, but that's okay. It still kind of works. I'm going to say 4 minus, in parentheses, negative 2x. What can you simplify this to? Well, double negatives. 4 minus negative 2x becomes 4 plus 2x. Number 11 is 4 plus 2x. In number 12, h of negative 4a, I'm going to say negative 4a in parentheses squared plus 1. You need to square the negative 4, and you need to square the a. Negative 4 squared is what? What's negative 4 squared? Negative 4 squared should be positive 16. Square the a. Don't think too hard. What's a squared? Well, just a squared. Don't forget the plus 1, though. Our answer to this problem is going to be 16a squared plus 1. Number 13, f of a plus b. Well, I'm going to replace my x with the more complicated a plus b, and I'm going to stick it in parentheses. I'm going to get 2 times in parentheses a plus b minus 2. To simplify this, what are we going to have to do next? We need to go and distribute the 2. When I do that, I'm going to get 2a plus 2b minus 2. That's my final answer. What happens if you plug a plus b into the f function? You get 2a plus 2b minus 2. Number 14, g of a plus b. I'm going to get 4 minus in parentheses a plus b. What are we going to have to do next? We need to distribute the negative. Or, if you'd rather think about it like this, we can say distribute like the negative 1. That was before the parentheses to both of them. That's going to give you 4 minus a, negative 1 times b, gives you minus b. 4 minus a minus b is your final answer there. I want to see if you can go do number 15. See if you can go find g of a minus b. This should be 4 minus in parentheses a minus b. Distribute the negative. 4, negative 1 times a is minus a. Negative 1 times negative b plus b. Make sure you didn't say another minus b. It should be plus b over there. Now, in number 16, I want to do h of a plus b. My h function is x squared plus 1. So when you plug in a plus b, you're going to get a plus b in parentheses squared plus 1. Now, to square something means to multiply it by itself, because you know that 5 squared is 5 times 5, 25. You know that a squared is a times a. If I want to do a plus b squared, I need to multiply a plus b by a plus b. And then we'll say plus 1 at the end. We are not allowed to distribute this square to the a and the b. It doesn't work that way. I need to multiply a plus b times a plus b. And how do you multiply a plus b times a plus b? Well, you FOIL. Actually, Mr. Elbert doesn't like that word. We can distribute. We can multiply the a times the a times the b times the a, the b times the b. Let's do this together. When you do a times a, well, a times a is going to give you a squared. When we do a times b, we're going to get ab. When we do b times a, we get ba, but how about I write it as ab because it means the same thing. And when I do b times b, I'm going to get b squared. And don't forget about the plus 1. There's a tiny bit of combining like terms you can do over here. A plus b plus a plus b is going to give me 2 of those a plus b's. So I'm going to say a squared plus 2ab plus b squared plus 1. And that's my final answer to that. A squared plus 2ab plus b squared plus 1. By the way, I don't really care what order you write the terms in. If you say a squared plus b squared plus 2ab plus 1, or put the 1 first, the order's not going to matter for right now. Later on, as we move through the rest of the year, we will sometimes pay attention to specific ways to write them. Don't worry about that for right now, though. Number 17, h of 2a minus 3b. Our function h of x is x squared plus 1, just to kind of remind you, because it's cut off in the video. See if you can figure out h of 2a minus 3b. This is about as tough as these are going to get for right now. See what you can do, and when you have an answer, send your answer into Edpuzzle. And to type a square, if I want to say like x squared, I can type that in as an x, the little power key, which is going to be Shift 6 on your keyboard. X raised to the second is how you can type that in. See if you can do h of 2a minus 3b. Okay, so this is going to be 2a minus 3b in parentheses squared plus 1. I hope that you then wrote it out twice and said 2a minus 3b times 2a minus 3b. We're always going to have to do that if we want to square a sum or a difference. We have to write it out twice and then FOIL, or double distribute. Now, 2a times 2a will give me 4a squared. 2a times negative 3b will give me negative 6ab. Negative 3b times 2a will give me another negative 6ab. Negative 3b times negative 3b will give me plus 9b squared. And don't forget there's still that plus 1 at the end. Combining like terms, I've got 4a squared minus 12ab plus 9b squared plus 1. And there we go. In the next video, you're going to see that we can also kind of plug, well, I'm not even going to say anything right now. You'll see that in the next video, that we can plug in things more complicated than just numbers or things with variables in it. That's coming in the next video.